So now we're going to have a look at Venn diagrams, and hopefully again you have seen these before at GCSE. So Venn diagrams are usually used for non-mutually exclusive events, where circles represent the separate events and the overlap represents the probability that both of them occur together. So in each of these Venn diagrams, we are going to shade in the area that is listed above, okay? Now for some of these I am going to end up rubbing some parts out, so just be careful that you're not copying as soon as I colour it in until I move on to the next one, and then you can copy it into your notes. So I'm going to work down the example list, then we're going to take a pause, and then you can work down the Now You Try list. So for this first example here, we're looking at the probability of A, which means that we're looking at inside the A circle, and that means the entirety of the inside of the A circle, including this bit here, which is also in the B circle. For the second example, not A means everything that's not inside that circle that we just coloured in. So it's not going to be any of that circle, which I'm just going around the outside of, but it is everything else that's within the square, within the rectangle. And it's really important that if you are to draw a Venn diagram, that you are making sure that you have the rectangle, because that's showing the bounds. That's saying that everything that we're looking at is within this rectangle. Next, we're looking at A and B. So if I was to, this one's one I don't want you to copy down straight away. If I was to colour in A, and I was to colour in B, sorry, choose a slightly different colour and then you can see it, there we go. Then the bit that I'm actually wanting is the bit where both the colours are overlapping, so where the green and the pink are overlapping, which is this dark section here. So we're not wanting any of this part here that's just green, and we're not wanting any of this part here that's just pink. We're only wanting the middle part, which is this part here. So it should just be this part here that's being coloured in, the overlap between A and B. For A or B, if you remember when we were talking about the definitions of that before, when we were looking at two-way tables, that means that it could be in A, or it could be in B, or it could be in both of them. So we leave it coloured in like that. So both of the circles, including the overlap, are fully coloured in. Next, we're looking at not A and B. So if we remember before, not A, sorry, A and B, so just this middle bit here, was representing this bit here where both of the circles overlapped. So if we're now looking, let me just rub that out now, that was A and B. If we're now looking at A and B not, that means everything apart from that little section in the middle. So it's everything else that's within my rectangle that's not in that overlapped part of where the circle for A and the circle for B are overlapping. So that's everything except for this bit here. For not A and B, so again, don't copy this down straight away. First of all, we're looking at not A, which I'm going to do in yellow. So not A is meaning everything that's outside the circle for A. And we're looking at B, so I'm going to colour in the circle for B. And we want where those two colours are overlapping. So I don't want this middle bit here because that was only coloured in green. And I don't want this outside section in here because that was only coloured in yellow. I want this half moon bit here that was coloured in with both green and yellow. And I'm just going to neaten that up a little bit because my rubber was a bit big and rubbed some of that out. So it's just this half moon bit here that's just inside the B circle, not inside the A circle at all. Next, we're looking at not A or B, so we're going to start colouring that in the same way. So not A is everything outside of that A circle. B is going to be everything that's inside the circle for B. And because it's or, we want where it's yellow or blue or both of them together, which means that it's everything apart from this half moon bit here that's representing A. Okay, and then there's just some spare ones at the bottom so that if you wanted to, you could practice some more of the drawings. So I'm just going to give you a second now to pause the video, and then we're going to work through the Now You Try. Okay, so hopefully you've paused the video and gone through the Now You Try list. We're now going to go through and answer that. So we've got the probability of B, which would just be colouring inside the circle that is representing B. We have the probability of not B, which is going to be everything outside the circle for B. We're going to have the probability for not A and not B. So we're going to start off by colouring in not A in yellow. And then we're going to colour in not B, let's say in blue. And because this is an and, I want only where it is yellow and blue. I don't want where it's just blue, and I don't want where it's just yellow. So this bit here that's just blue, I'm going to rub that bit out. And the bit where it's just yellow, I'm also going to rub that out here. So it ends up being everything that's not inside the two circles for A and B. So it's everything apart from those two circles and not the overlap either. Next, not A or not B. So this time, not A. So again, colouring in the outside of A. Not B means colouring in the outside of B. And this time, because it's or, we're looking at where it is blue or yellow or both. So everything should be coloured in apart from this little section here in the middle. Next, we're looking at A or B not. And if you remember, A or B was colouring in both of those two circles in their entirety because it means A or B or both. So A or B not is going to be everything that's not inside those two circles. Next, we've got A and not B. So if I coloured in the circle for A, and then if I coloured in the section which is representing not B, so everything apart from the B circle. And I'm then wanting only where it's both pink and green together. So I only want this dark section here. I don't want this bit here in the middle that's only green. And I don't want this bit on the outside that's only purple. So similar to the example in this section, it ends up being the half moon bit, but this time it's the half moon bit that's in A. Next, we're looking at A or not B. So A means colouring in the inside of A. Not B means everything outside of B. And because it's or, we want both of these two we want all of these sections here. We want where it's yellow, we want where it's blue, and we want where it's yellow and blue together. Now it's quite important to notice a couple of things. Here, probability of A or B not, if we have a quick look back, here, the probability of not A and not B is exactly the same. So it's these two here that I'm looking at. If I just choose a different coloured pen. So it's this one here, not A and not B, is exactly the same as this one here, A or B not. And this is because of a very important principle that also comes up if you study computer science with logic gates. If we have the probability of A or B not, this is the same as the probability of not A and not B. And if we have the probability of A and B not, then this is the same as the probability of not A or not B. Sorry, these shouldn't have a little flick on the end of them. Those out. They should just be U shapes. And this is called, I'm going to end up spelling it wrong, so I do apologise, De Moivre's theorem or De Morgan's theorem. And what it's meaning is that if we put our not inside of our probability instead of on the outside, then it changes the direction of the symbol. So you can see here we go from an or to an and we go from an and here to an or here, moving the not inside of our brackets. Now you don't have to know this, but it does make some of the finding of probabilities a lot easier. Next time we're going to look onto how we would draw Venn diagrams. So we have here articles made on a lathe are subject to 3 defects, A, B or C. A sample of 100 articles was inspected and the following results were obtained. So we're given here a big set of data. Now it's really important to note these numbers here, because if we were to add these numbers here, we would end up with more than 100. Okay, and that's because these numbers are sometimes being represented twice or even 3 times. So our first step here, step A, is to draw a Venn diagram. Now, as I pointed out before, it's very important that we start off with our outside so that we can have our region where everything is going to be inside of here. Next, we need our circles, which are representing our defect. Sorry about this, a bit hard to draw on here. I'm going to cheat a little bit. There we go. So one of these circles is going to represent A, another one is going to represent defect B, and the last circle is going to represent defect C. Next, we're going to have to fill this information into our Venn diagram. Now, as we do this, it's easiest to work from inside to out so we can tell which piece of data are being used twice. So to start off with, we have 6 had all 3 defects. So that means in this section here, where it overlaps A and B and C, we're going to have our 6 items which have all 3 defects. Then we have 10, working up my list, we have 10 that had type A and type C defect. So we're looking at where our circle for A overlaps with our circle for C, and that gives us this sort of half I bit here. Now that means that the total of this bit here is going to add up to 10, but 6 of those items have already gone here, which means that there's only 4 left over to go into that section there. Next, we have 13 that have a type B and type C defect. So again, in a similar way, looking at where B and C overlap, which would give us this section here. That's going to add up to 13. But 6 of those have already gone, so we've got 7 left over to go into that section there. Next, we're looking at 11 had both type A and type B defect. So looking at where, try and choose a different colour. Looking at where type A and type B overlap, this green bit here. That's going to add up to 11. 6 of those have already gone, so we've got 5 left over to go into that section there. Now we're looking in the actual circles. So we have 42 have type C defect. That means that the entirety of the circle that's representing C, so that's this circle here that I've just gone around in blue with, is going to add up to 42. But 4, 6 and 7 of those items have already gone into those 3 sections there, which means that we're going to have 42 minus 4 minus 6 minus 7. We only have 25 left over, so that means that in this section here we will have those 25 remaining items. Next, we're going to look at the circle for A. Doesn't matter if you do A or B first. Here we're meant to have a total of 31 items. Looking at this value here, I'll go back to B in a second. So that means that we had 31 minus 5 minus 4 minus 6. We only have 16 left over to go into this section here. And lastly, we're looking at the circle for B. B has 37 items, so that's going to be 37 minus 5 minus 6 minus 7, which leaves us with 19 items left to go into this section here. Now, if we have a look at those numbers, we have 16 and 5 and 6 and 4 and 19 and 7 and 25, and we can check we've got them all because we've got 1, 2, 3, 4, 5, 6, 7 sections, and we have 1, 2, 3, 4, 5, 6, 7 numbers, and they add up to give us 82. But remember, at the beginning we were told that we had 100 articles, which means that the leftovers have to go here. So that's 18 items that don't have a type A, a type B or a type C defect. So we're now going to answer some questions on this Venn diagram that we've drawn. So we're trying to find the probability that a randomly selected article from the sample had no defects, and we're looking at probabilities. So we can see here that 18 of them are not in circle A, B or C, but that's not a probability. We have to do that out of the total number of articles that we looked at, which was 100. Part C, we're looking at no more than one of these defects. So we're not wanting to have any of these overlaps, which means that we're looking at the 16, the 19 and the 25. So 16 plus 19 plus 25, which gives us 60. And remember again that we're writing this as a probability, so that's out of the 100 articles that we were looking at. Now we're told that an article is selected at random from the sample that had only one defect. Now this is going back to what we were talking about before when we were looking at two-way tables. We're now pretending that there are only articles that have one defect, which means that the total that we are looking out of is those 60 from before. And then we're wanting the probability that it has a type B defect. So if we have a look back at our Venn diagram, the type B defects are those 19 there, out of the 60 which only have one type of defect. So that's our probability. Next, we've got two different articles were selected at random from this sample, and we're trying to find the probability that both had a type B defect. Now, unfortunately, this is a bit ambiguous. It doesn't say if it's meaning that we're only looking at the ones that have a one defect, or if we're back at looking at our entire section of data. I'm going to read it as it's a carry on from this section here. So I'm going to read it as we're putting these two together. In an exam style situation, this would be a lot clearer. But here, when I'm saying that we're looking at the sample, I'm going to read it as only one defect. As I said, it's a bit ambiguous as to whether that's meaning the sample, meaning the 100 items, or the sample meaning the 60 that only have one defect. If we're reading it as only one defect, then the first item that we're looking at has a probability of 19 out of 60 of having a type B defect. And we're wanting the second item, because it says here that we're selecting two items, to also have a type B defect. It also doesn't state whether after we selected this article, if it's being returned to the pile or it's not being returned to the pile. So again, it's a bit ambiguous. I'm going to read this as it's not being returned. In an exam style situation, as I said before, it would be a lot clearer than this. So the probability that the next item has a type B defect, well, if one of those items has gone, one of our 19 items with a type B defect has been removed, we only have 18 of them left. Out of, we had 60 items that had one defect. However, one of those has gone, so we only have 59 of them left. So that's 19 out of 60 times 18 out of 59, which gives us 57 over 590, or we could write that as 0.0966. If you interpreted it as being out of the entire set of data, then instead of that, we would have a type B defect being our 37 from before, out of our 100 articles, if we were looking at everything. And again, if we still read it as it not being returned, so this time we're looking at all data, in case you read it that way. Once that item's been removed, we would have 36 out of 99, because we'd only have 36 items left. So that's 37 out of 100 times 36 out of 99, which gives us 37 over 275, or as a decimal, 0.135. I'm now going to give you a moment to pause the video and try the Now You Try. Okay, so hopefully you've given the Now You Try a go. First of all, again, we're asked to draw our Venn diagram. I do apologise, I am going to cheat again. So here we have our three circles, which are going to represent our swimming, our running, and our cycling this time. Whoops. Not liking me. There we go. So we're looking at swimming, running and cycling. Now you might have done these circles in any order, just make sure that you're reading it carefully when you're checking these. Again, we're going to look first of all at all three of these. It just so happens that this is on the bottom. The list could be written in any order though. So that 25 is going to go in the centre. 35 ran and cycled, so we're looking here. So that means that we're going to have 10 left over to go in this section. Swim and cycle, so now we're looking at the swim and cycle overlap, which means we'd have 5 left over to go in this section here. And here we've got run and swim, so we're looking at this bit here, which leaves us 15 for this section. Then we're looking at just cycling, well we've got 10, 5 and 25 already in our cycling circle, which adds up to 40. We had 60 in total, which leaves us 20 left over for just cycling. For swimming, we're meant to have 48, but we've got 25, 15 and 5 already gone, which adds up to 45, which means we have 3 people that only do swimming. Lastly, for our just runners, we're going to have 10, add 25, add 15, which means that we already have 50 people, which leaves us 15 left over who only do running. Remember to double check how many that adds up to. And double check you have all your numbers. Again, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, which gives us 93, which means that because we had 100 people, there are still 7 of them that haven't been accounted for in any of those circles. Now going on to the questions that go along with this, we're looking to find the probability that a randomly selected person from the survey takes none of these exercise. Again, we're talking about the probability, so that's going to be 7 out of 100. Next, we're looking at swims but does not run. So we're looking in our swimming circle, but we don't want to include the 15 or the 25 that swim and run or swim and run and cycle. So that means that in total, we only have 8 out of 100. Next, we're looking at take at least 2 of these exercise. So that means that we're looking at our swim and run, swim, run and cycle, swim and cycle, and run and cycle, which in total gives us 55. So that's going to be 55 out of 100. Next, we've got Johnson is one of the above groups. Given that Jason is in one of the above groups, given that Jason runs. So we already know that Jason is in this circle here that represents running. Find the probability that he swims but does not cycle. So we have to look at those people here that swim, but we don't want to include those that also cycle. So we're only looking at those 15 people out of the 65 people that run. So that's 15 out of 65. On our next video, we're going to have a look at the addition rule. Thank you very much for listening.